do want to say a little bit about the rational number class. This one is a project that you will revise in Unit 8. So the overloading is also a modification to the rational number class. So you need to be aware of that, all right? So this won't go away, and you need to be ready to do some modification. It's actually a really neat feature of C++, and I think it makes a lot of sense. And so the rational number class leads us very nicely to that. And then we revisit it one more time in Project 11 as exceptions. So we'll retrofit the rational number class with exceptions. That will actually be a very simple modification. The overloading will be a significant addition to it. So we'll be using this rational number class a number of times. Unlike the other projects that are, do once and throw away. Okay. So we are now beginning to look at the object-oriented feature of C++. Right? C, the language C, was developed way back in the 70s along with the Unix operating system. C was the programming language that provided a very low-level expression of bit operations. The less than sign and the greater than sign are actually bit shift operations in the original language, and the plus and minus that we all come to love in Java really came out of C. And so it's been around since the 70s. But in the 90s, when object-oriented was realized to be a really good idea, Bjorn Saustrup augmented the C language, called it C++, like the humor, right? That we are now one iteration next up from C to C++, right? And he modified it to be an object-oriented version. It's really a convenient language. I like it because when I don't want to do objects, I don't have to, as the first 5 projects has indicated, right? You haven't really instantiated any objects yet. So now we are going to go more traditionally into the object-oriented program. So this will rely a little bit conceptually on your understanding of objects in C from Java and apply it now to the C++. There will be some significant differences between C++ and Java, so they'll now become more apparent, although there's a lot of similarities. The interesting thing is that the syntax of Java pretty much was taken from C++. But when we get to this object-oriented concept, things are significantly different. So 2 things I want to begin addressing today is how you think about programming objects and classes in C++. And then think about, as an application, how you should consider the rational numbers as a class, as a new type. A lot of object-oriented thinking is often creating a new type. When you build a class in Java, it's a type, right? You can declare a variable of that type. Then you have to instantiate an object that variable points to. Okay, so we have those ideas as well in C++, although a little bit more flexible. It won't be the case that a variable necessarily points to an object. It may be the case that the variable is the object. All right? Well, you just are working on, or you will be beginning for next week, a unit on pointer fun, where a variable can be a regular variable or it could be a pointer to something. And after last week's review, I was showing someone that you could actually have a pointer to a pointer. So C and C++ allow a high degree of flexibility. That will also add to complexity that allows for a lot of debugging opportunities. Okay, I say that sarcastically. Yeah, sometimes debugging can be a little more challenging because of the fact that you can get down and play with the pointers. All right, so let's begin with essentially, let's talk about the rational numbers first, right? And it gives us the context under which we can then look at how you express classes in C++. So the rational number is simply the form of an integer over an integer. If you remember that, 1/2 is a rational number, 3/4 is a rational number, 2/4 is a rational number, 5/10 is a rational number, but what is interesting about that is these are, of course, equal, right? And so one of the things we will want to do is keep rational numbers in reduced form. Right? So you have, the rational number set is a non-unique number system. Right? There's an infinite number of ways to represent 1/2. Okay? So an infinite number of ways to represent the number 1. 1/1, 2/2, 3/3, million/million. Okay? But it's an integer over an integer. So the rational number, has two parts, right? A numerator and a denominator. And so that's how we'll design the class with those two instance variables, numerator and denominator. Okay? So keep that in mind. It's a simple class. There are only two instance variables in our class. If you're thinking about this in Java, for example, you'd have two instance variables. Okay? Regardless of what we want to do with that rational number. Okay? Numerator over denominator. And they're integers, so we aren't going to consider complex fractions in any way, shape, or form. No doubles. Everything's still an integer. All right? Keep things and that's where it gets a little bit interesting, is how to effectively keep your rational number in reduced form. So you should never, while you do a calculation, you might generate numerators and denominators that are not completely reduced. But when you're done with your calculation, you should leave the result in reduced form, which means that there's no common factor in the numerator and denominator that can't be removed. Right? So, 5/10 needs to be reduced to 1/2. 2/4 needs to be reduced to 1/2. 7/21 needs to be reduced to 1/3. Right? So you need to identify, figure out how to reduce and keep things reduced. Okay? So that's a reminder of the rational number system. Right? Your task, if I don't know how quickly I can find the the exercise. It's in the 9th edition, 8th edition. It's page 411, talking about what you're to implement. What you need to be able to do. So the capabilities of our rational number, and I'm just going to call this rational. So we'll just call the class rational. All right. So the capabilities, we want to be able to add two numbers. We want two rational numbers. We want to be able to subtract. We want to be able to multiply. We want to be able to divide. All right. And when we add and subtract and multiply and divide two rational numbers, the result needs to be in reduced form, and we would want to display, we want to print rational, and we want to print fraction. Okay, I think in floating point, print float, and let me change that to print FL. Okay, so 6 methods: add, subtract, multiply, divide, and print in 2 different forms. So that print rational, you would actually print 1/2. Print float, you would print 0.5. Basically, you divide the numerator by the denominator and get the printing answer. It's trivial, right? It really is trivial, right? Whereas print rational is you print the numerator and a slash in the denominator. Okay, so there you go. I'll give you the code. There's nothing fancy here. All right. Let me remind you of how you add and subtract and multiply and divide rational numbers. Okay. You remember this from, what would this be? 3rd grade, 5th grade, 6th grade, 7th grade, where you actually were exposed to the rational number, thinking about fractions, adding fractions, right? Adding fractions and subtracting fractions. Do you remember how we add fractions? We have 2 rational numbers, a over b and c over d. Remember this formula? AD plus BC over BE. Do it. That's what you do. However, you're going to end up with a number, most likely, that's not in reduced form. Okay? Right? If I'm adding 1/2 and 1/4, okay, I'm going to get 4 plus 2 over 8, which is 6/8, which is really 3/4, right? So this formula is invariably going to give you an unreduced rational number. So you will need a method that will be reduced. These will all be public methods, by the way. Yes, we will use the word public and private. Reduce is going to be one of these methods. It's a nice one. Yeah, I love this example because it really introduces a whole lot of object-oriented capabilities, object-oriented thinking that you should be doing in Java, but maybe don't really have the opportunity to. So here's a good example of a private method. You'll use it all over the place, but there's no reason that the user has to give it, has to call it. You shouldn't burden the user to reduce. Do it for them. Don't burden me. This is a good example of that. Okay. Subtraction, of course, is AD minus BC over BD. Right? So subtraction is exactly the same as addition, except you subtract these two products. AB times CD is what? AC over BD. Right? Remember that? Not hard. Again, You compute a numerator and you compute a denominator, but you're going to have to reduce it. AB divided by CD will be AD over BC. This time around, and for the overloading example, and ultimately then, not until the exception project, we won't worry about zeros creeping into the denominator. Right? Normally, we have to prevent that. Zero in the denominator, if I go next door and ask what would mathematicians think about zero in the denominator, and they're going to say, of course not, it's undefined, right? You don't have a rational number with a zero in the denominator. Okay? So we're going to eventually want to prevent that, and that's a great opportunity for exception handling. If a zero shows up in the denominator, boom, throw an exception, or kick an exception. That's what I was. Throw an exception. It's not my problem. It's not the rational class's problem. Don't print an error message. It's not your problem. You throw an exception. You make it the user class. All right? Questions so far? Anything? Make sense? Just hopefully a nice mathematics reminder of this number system. All right? So that's the context. All right? Now let's see how we sketch this out in defining classes in C++. And I'm sneaking over here to the book so that I can remind myself of the syntax. I always have to cheat. All right. So when we define a class in C++, we now create two files. A class consists of two source files. You will have an H file. Let's see if I can throw this away. So we have a rational .h file and a rational .cpp file. Right. Up to this point, you've only ever created .cpp files, but that's because you weren't creating objects or classes. Now you're creating classes. You have an H file and a CPP file. This is known as the header file, hence the H. It is C++, but you only put in the H file essentially the public information. Okay, you only put in the H file what it is you want the user to know about. Unfortunately, you have to give up a little bit of the private stuff too. But you don't have to you don't put the code here. You don't put the implementation of things. This is where you do declare your instance variables and your method headers. Okay? So I'm probably going to give you most of the H file just to get us started, so you can see how classes are defined. I'll just go ahead and do that. The book, by the way, puts in a pattern with, I'll just go ahead and put it up here. You'll see this. You have pound if and def, and then you usually say the name of the class underscore H. Pound sign define rational class. Just get used to doing this. It will save some issues later. And then the actual class stuff goes inside, and at the bottom you will have pound sign and if. All I'm going to say right now is just put those 3 lines in. There's 2 at the top and the 1 at the bottom. You'll see every example of an H file in your book doing that. All right? Just do it. All right? We define the class. This doesn't look too surprising. Class rational. Open brace. Instead of repeating the public keyword like we do in Java, you actually have a public section that you just simply say public colon. All right? And actually doesn't matter. You could put private up front and colon and then public later. So and you can even alternate if you wish. All right? In public, we're going to have let's see, void add, void subtract, void multiply. You get the idea. All right? And then private will be typically your instance variables. And we want int, num, int denom, or you can spell it out, numer, denom, pick your poison, and void reduce, and there will be one more in here called GCD. And they will have parentheses after. Add, subtract, multiply, and divide will all take a parameter. Rational x. Rational x. Because if I want to add two rational numbers, I need to pass the second number as a parameter. The first number is the object itself. The second number is the parameter. That's how I'll add to it. And I'm going to add x to the current value. I'm going to add x to or subtract x from the current value. I'm going to multiply. I'll show you here in a minute. All right. What I'm doing is setting up the H file. And this is all you do here. You don't describe how you do the add here. You don't describe how to do the subtract, the multiply. You don't describe how you're doing reduction. You don't describe how you are computing the greatest common denominator, which is the factor by which you would reduce the numerator and denominator. GCD, please look up GCD in your book. Go to the index and look up GCD. It will be there. And in the 8th edition, GCD is found on page 262, which was way back in another chapter. And you'll find it actually in the exercises. There's a GCD method on page 262. It's right under the Towers of Hanoi problem. Recursive greatest common divisor. Right? The algorithm is buried in that exercise. I want you to use it. It's a recursive algorithm. If you don't know recursion, just code what's there. It's not hard. Don't think about it. There are no while loops. I don't want you to use while loops to compute the greatest common divisor. People will start and just say, well, I'll keep testing numbers and see until I get... No. Greatest common divisor is one of the most amazing algorithms discovered by Euclid, I think. All right, so I have that right. Guys, people next door will correct me on that. So use it, right? So look it up, use that. If you don't, I'll tell you about it. I'll mark it, and you might have to redo your program. Right? Okay. That's the H file. That's the H file. And the rational class, and then the end if. That's what goes into your H file. You do not essentially compile this. This is the interesting thing. The H file gets included. You've been putting includes in your programs up to this point, right? You've included stdio and stream.io or a couple other things, math.c and a few things like that. This now is a file that is included. You do not compile this. It gets compiled through the inclusion, but you do not compile separately. There's nothing to compile. There is no code here. It's all declaration. There's nothing to execute. It's just declaration. Okay? Now, before I go to the rational.cpp, let me show you how we will use these in the main program. Okay? So in your application, you'll do the usual, in your application, you will now say include rational.h. And you do use double quotes, not the angle brackets. Right? When you have your own H file, make sure you quote it. The angle brackets actually say go into the system library and find those. Right? So the double quotes say I am providing it. Right? So your main program, so you have the usual, main blah blah blah, int main. Here is where you ask the user, give me a, I missed one other thing. Constructors. Yes, you will have constructors, rational. And this is where you would pass in 2 integers. You may have a default constructor. Oh, this is always a good question. If I have a default constructor for the rational number, what should it be? What would make the most sense to create as a default rational number? I always like to ask this question because I never get the right answer. You work too hard at this.
0.
Thank you! Oh, you didn't work too hard at it. And how would I express that?
0 over 1.
0 over 1. Yeah, please not 0 over 0, because we already had that discussion that zeros never should show up in the denominator. But yes, as a default constructor, create a 0 over 1. As a non-default constructor, let the user pass in 2 integers, the numerator and denominator. Okay? And reduce it. Your constructor should call reduce immediately. Say, okay, I know you gave me 5/10, but I'm going to reduce it. Okay? So your constructor should turn around and call that. Getters and setters, not too useful. Right? You would never, by the way, set the numerator without setting the denominator. You may have a set value method that changes both. If you want to change both numerator and denominator, just go ahead and set the value. That's okay. So you do feel free to add, conveniently a few more methods as you see fit. I'll go back over this next week. I'll give you a second round of this as I go. Oh, actually, what time is it? Is it 4:30? Okay, so I don't want to do a whole lot more, but I want to kind of get you started. I won't talk about how maybe the rational numbers actually get in there. But I'm just going to assume, for example, I have rational A, B, C. Right? I'm able to create a class in C++, which gives me new types. Okay? And so think of rational like I want 3 integers. What do I say? Int ijk, int abc, int xyz, double xyz, char xyz. If I want 3 characters, I declare them. If I want 3 rational numbers, this is how I do it. You know, a lot of students will read this exercise and, oh, I've got to add 2 rational numbers. The next thing I know, I'm getting classes that have two denominators in it and 2 numerators. What kind of object is that? We want the object to reflect the mathematical structure, a rational number. All right? So I have 3 rational numbers. Somehow magically A, B, and C get set to something. But I want to show you that I want to say, I can do this. I can say A equals C. C equals B. Right? The assignment is legitimate, but I need to tell you it's different than Java. This is a subtle difference. Notice here what's missing. I really didn't instantiate 3 objects. I declared 3 objects. I didn't declare a pointer to these objects. I declared 3 rational numbers. I do have, at this point, 3 numerators and 3 denominators. The new is missing, right? I didn't have to say A equals new rational. C++ does give that to you, but then I needed to declare this variable to be a pointer. How do I declare pointers? Has anyone worked on that chapter yet?
Yeah, you have your type in star.
A star, an asterisk, exactly. So there is a difference. Rational, P is not a choice, R. That will point to a rational number. When you knew a rational number, you must have a variable that will point to that. For this project, we don't have to do that. Right? This is a little different though. You need to realize that you now have, so instead of me saying A points to, you've seen me do this drawing, A points to an object. That's not the case. A is the object. Just like I would draw a variable int, the primitives in Java, I would do that, right? Okay, so somehow in here, and this is what I'll do next week, the values get into A, B, and C, right? So we've loaded it. But if I want to add B to A, this is what I would use. I would say A dot, at the dot notation, just as you do in Java. Take the object and apply the add method to it. But what are you adding B? Right? So the effect is A equals A plus B. So B gets added to A. A is changing. You are destroying A. The old value of A gets changed. It gets to be the sum of A and B. Right? That's to be the case for all 3 of them, all 4 of those arithmetic operations. Okay? One other thing before I let this go. All right? So this is the application.cpp. Let's just call it app.cpp. Right? The third file. This is going to be normal. Any submission from here on out should be an odd number of files. You will have an application file, and then you will have pairs of H and CPP files representing your classes. So there's a project that has 6 classes. So that's 12 files plus an application. So you will be submitting 13 files. I love that one. All right, so the third file is rational.cpp. No surprise. Okay. And the first thing that you will have in here is include rational.h. Right? You do not compile, and Visual Studio will take care of this. You don't explicitly compile H, but you have to include the H file in both of the CPP files. So H files get included. You have to go in both places. This is how the application knows how to use the rational. So the body of the code that we're describing here will go in rational.cpp. But as far as the app.cpp is concerned, it has all it needs to know with .h. It's literally capable of compiling this with the H file and not have any clue where this guy is. This is the information hiding. Some of you have had me and I've talked about information hiding. This is CPP's version, C++'s version of information hiding. This is the user code, this is the implementer code. And the only thing that needs to be shared is the H file. This is the interface, if you will. And that's what's public. So down here, we would again say class rational, all right, open brace, and now it looks a lot like Java, and you would say, void add, taking a rational x, and now the actual implementation of A times D plus B times C over BD. Right? You would actually do that calculation. You would have the rational constructors, just like Java, do not have types. They are themselves a type. So the constructor rational would be simply numerator equals 0 and denominator equals 1, just as nicely suggested. There's your constructor. I already give. There's the default constructor. Rational, open close parentheses, brace. Not more style than my space on the board allows. Right? But I will expect you to do that. And then this one would be a little different. All right. So that's an introduction. I know there are still some pieces that need to be filled in. I will do that next week. Right, to be sure that you got everything ready to go. And then it's not really due till March 6th. You've got time to do it, but there's a lot of pieces to this that I want to be sure you have down. Question?
Is it alright if we set the defaults in the header file rather than in the...
Yeah, you can do that. I wasn't going to worry about those details. Yeah, you will find other ways of doing things. Do you have the edition 9?
No, it's the same.
Okay, all right. And edition 9 does some other things I don't even understand. I mean, I can figure it out, but I haven't studied them. So, but this should be the general organization. Any questions on that?